Again, we're going to talk a little bit about resiliency-based performance standards and resources. And it amazes me that I started looking at resilience in 2008 and how it's taken almost 10 years for a lot of the government and many entities to catch up. But certainly most of us are aware of sustainability, but we may not be aware of resilience, which if we look at this lower box, we're really looking at climate risk assessment. We also may be looking at more things other than just buildings. We may be looking at our landscape and the land use around those buildings, which comes into site planning and so forth. But for me, really, when we look at sustainability and resilience, they are linked. And they are linked in such a way that we cannot really unlink them. And when we design, we need to have consideration because, as Claude said, anytime we turn on the TV today, we are looking at what happens across the world with natural disasters. Certainly, if we look at those disasters reported by type, this is some world data that comes around, we can see that substantially there are earthquakes, but more so than anything, we see flooding, extreme weather events, and so forth across the world. And with these disasters are economic implications. In the United States alone, we had an unprecedented amount of economic losses last year due to natural disasters. Worldwide, it equates to about $150 billion in 2019. More so, there are measurable impacts that we can really not account for. And there's no economic value that we can place on the loss of life or other items such as our loss of social capital, our loss of cultural identity. And certainly these are very important to us in our communities and as individuals. I use this slide, and we actually talked about this slide yesterday, that a lot of people don't really understand it or don't like it. I tend to like it because it really says, if we look at traditional sustainable design, and when I look at traditional sustainable design, I'm looking at reductions in CO2 or reductions in environmental impacts. Really today, when we talk about sustainability, you must have those, iconic ideas when we look at design, which means that we're lowering our environmental impacts, we are positively influencing society, we are, being economically accountable, but we must also link in their disaster resilience, because if we build a building under the traditional sustainable guidelines such as LEED, we are not, if it is not disaster resilient, it truly isn't sustainable. Many people say the most sustainable building is the one that lasts or is still standing. Now, a lot of people don't really understand the difference between sustainability and resilience. I like to really boil it down very succinctly. Sustainability is assessment usually concerning ordinary events that have very high probabilities and low impacts. So such as your day-to-day operations, your day-to-day maintenance, whereas resilience really deals with assessing those extraordinary events that have relatively low probabilities and high impacts, such as possible loss of a building in an earthquake, major flooding, a tsunami. Those are the types of things that we really think of as extraordinary events. The problem with resilience is it's really quite complicated. It's kind of like a lot of people say it's the new sustainability. It is, but it is not. I like to look at resilience from really a very high level in many regards, where I'm looking at it from a worldwide level, versus the lens is what you make it to be, such as my big eyeball there. Everyone has a different lens. We may want to look at it at a country level. We may look at it at a state or a provincial level. We can then drill down into a regional level, to a local level, and then come down to a structure level. It's very multidimensional as well, because we are looking across multidisciplines, where we will be looking at the functionality of a structure, its failure mechanisms, the mode to recovery, its adaptation, But certainly then we must also consider the multiple stakeholders. We have investors of those buildings, and then who are the beneficiaries of having more resilient design? Certainly we have a lot of people that look at resilient communities, and this is really where we see the United States and many other countries are looking at how do we make more resilient communities. And I kind of look at this as one level above our building structures, or where we're looking at how do we return our citizens to work more quickly, how do we reopen our business, or really what we say today is how do we get our economy rolling again so that people can return to their quality of life. I also like to look at resilience a little bit differently, and Steve Zoke actually coined this term functional resilience, and I really do like it because a structure needs to maintain its integrity, and so its function or its ability to house people and to be inhabitable needs to be restored. Now, we think of disasters as climate-related disasters, but we also have other terrorism type stresses. We also have day-to-day stresses, and all of these are very dependent on the resilience of the structure itself. Now, why are community resilience and functional resilience linked? Well, obviously, we need to have structures that have the ability to protect and provide public safety, and we need to be able to recover quickly and efficiently. So when we look at these, as we said, as the lens, if we have functional requirements for our energy, our transportation, our communication, and these are all segments, these impact our economy, as we've seen right now in the pandemic. They also impact our beliefs, our cultural government, everything is impacted. And so they really go together. So one of the issues with resilience is that at looking at different levels, some of us may focus on the vulnerability aspects of resilience, which is what is our resistance to the event, where others may be focused more on the human capacity, which is to recover or bounce back or to adapt to the changing climate. So again, as I said, resilience can be quite complicated when we view not only it from a structural level, but when our structures are linked to society, we again have to take into consideration these other lenses. And so when we look at planning and preparing and absorbing, we really go through risk management exercises. And I am not going to steal Jeremy's thunder because I'm sure he's going to go through this. But when we really look at risk, we're looking at the hazard versus our vulnerability and also the consequences that come with not being as prepared, or the consequences resulting from the hazard over time. And certainly what we try to do is reduce our risk caused by the climate. And certainly this is based on a lot of science, which I will let Jeremy tackle, but typically we look at things like fragility curves and economic benefits and losses. And really when we look at risk assessment, it's a trade-off. You know, if we have a climate hazard, how are we reducing our vulnerability or enhancing our resilience or reducing our exposure to receive some reduced impact and benefit? And I'll show you this book at the end, but I love this book that was out late last year. And it really succinctly talks about how we balance these things across many different sectors. But when we talk about risk-based planning and tie it back to buildings, it really is tied back into the codes. Codes are really the principal mechanisms that regulate the design and construction of structures. Most often they are life safety and collapse prevention based. There is no regulations today as it stands across the US building codes that ensure that buildings will be usable after a disaster. Now, with that being said, 318 has started a subcommittee, Subcommittee N, on sustainability, which also is tackling this idea that how do we make our buildings more sustainable and how do we make them more resilient? It's going to be in code language, but again, we're taking baby steps in the code. Unfortunately, it's in my opinion, we're lagging where we need to be to provide safety to everyone that is involved in these types of disasters. And certainly we're seeing changes in codes throughout the world, but they are slow to adoption. And the other complication is the measurement. And how do we measure what is resilient and what is not resilient? So as I said, it's a very complicated issue. Now, when we talk about resilience, there's many different definitions. When I look at a structure, it's really the structure's ability to withstand some impacts of an event. So we might have a minimum level of functionality after an event, or we may be fully functional after an event. More often, people look at this as the time required to return to normal functioning after or following an event, a disaster event, a storm event. People don't like the word event. You might call it an advanced loading, say snow, wind, rain. And really what we have to do is, how do we assess that building after it's gone through this event? And so last year, really, there was a very interesting group called Building Resilience 19 that was in Cleveland, Ohio, with a lot of interesting speakers talking about these types of issues. And there's not agreement across everywhere. What I like to look at is really when we talk about a building is, I do like this diagram from the National Academy of Sciences, that you have some sort of failure mechanism, whether it's the brittleness of the building, it's how ductile is it, the graceful failure, and then what kind of recovery event are we looking for? And I'm going to show another graphic that makes a little more sense in the future, but really when we're talking about this performance criteria, this is really the current focus on resilience, is our plan and preparedness. We're still working on how do buildings absorb and how does the community absorb this event, you know, and then obviously we have this recovery period. And now the recovery period, how well we recover will really help us as far as economics and the return to normalcy, or to return to a normalcy that is better, that could be worse, or that is equivalent to what we were seeing before. And so we can see the key down here, but worse than old. And then this slope is going to tell us how fast we're recovering. And so certainly we see that there is an adaptation portion. And we've often seen that many countries that have gone through these types of events have not really returned to their normal economic boom, such as if we look at the tsunamis that hit Japan, that region has not yet recovered, nor will they probably recover from that event. Their automotive industry is gone, those jobs have been lost, and those people are still rebuilding their lives, such as we see as in Katrina in the US. So now I'm going to go through a brief review of some of the industry standards and resources that are available to us. My apologies there. This is the slide I really like to look, and this was a workshop I attended in actually Washington, DC. This was done by FEMA and also the National Institute of Building Sciences. And as we can see, if we take that same graph but make it a lot less complicated, how robust we are in our buildings, or our capacity, will really, how robust we are will really determine how prepared we're going to be and how fast our return to operation will be. So if we have an asset that has very low resilience, we're going to follow this red line where we're really not going to recover. We're going to still have issues returning to normalcy. We're just not going to get there because we can't anticipate the, say, the additional snow load on a building or the additional flooding that's happening in your area. We might have a medium asset building, which it may resume operation, but it's going to take substantial time to get back to that normalcy. And again, we might have to have some contingency recovery plans. Ideally, we would like to have the ability to return very, very quickly with very little reduction in service. That is really, truly a resilient structure a resilient community, and really a resilient country in many regards. So why is this investment in resilience so important to us? Many of us might look at this as exceeding the minimum design requirements, because as anything, when we look at resilience under a similar lens to sustainability, we realize that there are some societal benefits. Many people that go through these disasters are suffering PTSD, there are injuries, there are long-term job losses, there are deaths, and certainly there are environmental benefits by enhancing construction materials. FEMA did a study, what used to be for every $1 invested in hazard mitigation strategies, you would save $4. Well, they reevaluated that about 2 years ago and now have found that is really for every dollar that we invest up front, and that would be in resilient construction, that would be in fortification of our existing structures, we can save $6 in disaster losses. So there is a very large economic implication in having stronger building codes. Many of us have seen that there's been very little legislation over the course of the last, I would say, 20 years. I'm just going to go over a little bit of the legislation that has been spearheaded by the concrete industry. This was spearheaded by NRMCA. This was in 2013. Those things that were spearheaded were the Safe Building Code Incentive Act of 2013 and the Disaster Savings and Resilient Construction Act of 2014. These are where they were offering credits to tax credits to those people that would use life and property saving techniques in construction. So these were using some ideas that were coming from the Institute for Business and Home Safety, using their Fortified for Safer Living and Business. And we'll go through some of these systems in the future. There was also some amendment for the Water Resources Reform and Development Act, again, to help resist hazards due to a major disaster. And this was done by the Corps of Army Engineers, along with the National Academy of Sciences, to consider the reduction in long-term costs and vulnerability of our infrastructure. As many of you know, much of our infrastructure is quite dated. It is in need of rehabilitation and fortification. So when I start looking through the literature, and this was a very good exercise for me because it's been, while I keep up with the literature, it's been a long time since I kind of reviewed where we've been and where we're going. And really in 2017, did we really start to see where there was an impetus to have design professionals to start considering resilience and climate-related risks. And this was done by the U.S. General Services Administration in 2017 in their publication 100, where they actually asked professionals to exercise judgment in the context of resilience and climate-related risks for an evolving professional standard of care. So when we start using more of this code type language where we say the professional standard of care, now we're asking them to consider including resilience. So some of the major influences that I have seen in the last, I would say, 10 years have certainly been with the onset of disasters and seeing how the insurance industry has responded. And as I said previously, we are really seeing multiple stakeholders that will influence the building code and that will influence our ability to move forward with a design policy. And certainly when we saw hurricanes and then the rebuilding of these structures on the coastline, now we've seen them allowed to be built back the same. But they go through another disaster and again, another insurance claim. Now we're seeing things that they are actually asking them to build them at a higher height, build them out of concrete, make sure they are secured with metal straps. These are changes that have happened and that are influencing the building code for a safer environment for people. Recently, I just looked at as well the resilient adaptation, the Center for Sustainable Building Research out of the University of Minnesota. I really like their look at their resilient goals, where we're looking at what happens when we have no power. Well, can we maintain someone in their home at that time having a habitable temperature? Case in point, we have designed over the last several years without operable windows. Well, when we go through a heat wave and you have no air conditioning, that building may no longer be inhabitable because it's just simply too warm to stay in there. Then we look at closed water systems and shelter. These are all terms that we call passive survivability, where you are able to shelter in place. So our building codes have why they allow us to stay in the structure and maybe evacuate safely. They are not built for us to stay in the structure in a way that we could still survive for a week or 10 days. Unless it's built that way, you're probably going to have to evacuate the building. A lot of this, as we see, LEED has always played a very large part in some of the codes and how the codes have changed. They started looking at green building and climate resilience in 2011. And since then, they've really looked more about, it's more about disaster recovery. And really, they now have moved it more toward, am I looking at the long-term planning of a structure? Am I looking at short-term survivability? Am I looking at durability and flexibility and responsiveness? So I do like to see that LEED has grown, is looking more toward the future in the planning. And they have actually included some credits most recently in, these were pilot credits, pilot credit 98, 99, and 100. And we can see that there was assessment for planning for resilience, designed for enhanced resilience, and then passive survivability. And so they would ask you to assess the hazards, which was a prerequisite to receive the credit. And many of us may or may not be familiar with the LEED rating system, but often they have driven a lot of code requirements and a lot of the, what I would say, carbon credits and so forth, and many of the governmental regulations that are out there today on the West Coast. Some of the other things that I have seen in the literature, and again, these have all been coming over time, is that FEMA, the Federal Emergency Management Agency, has looked at how do we provide for community resilience. And many of those ideas have been based around community planning. And so they have offered some guides as to how do we appropriately look at hazards. When we look at resilience, we look locally. You cannot plan for snow in California, you plan for snow and heavy loads maybe in Minnesota. And so we're going to have different weather events in our regional areas. And so while we look at the graph on the left, we see that there has been, routine 50 to 60 years looking at what will happen as the snow levels. But unfortunately, we have not experienced some of the extreme weather that we are experiencing today. So a lot of the modeling that we see that goes into the codes, we really can't account for because we are looking at historical data versus really what is happening today. One of the other areas that I really like to look at is this proposed amendments for high performance buildings. And I'm not going to take this away from Steve Zoke because I know that he worked very hard on this kind of amendments that would go into the International Building Code to take it to a higher performance level. And again, we have not in the past ever been able to design, we're looking at historical design of extreme loadings, not what we are typically seeing today in some of the extreme events. When we look at industry collaboration, we have seen a lot of collaboration in the cement and concrete industries worldwide from both a sustainability and a resilience lens. Some of the external collaboration that has gone on are with the following agencies, such as the U.S. Resiliency Council, Federal Alliance for Safer Homes, the Community and Regional Resilience Institute. There is an Institute for Business and Home Safety, National Institute of Building Sciences, and the Mitigation Movement. I'm going to go through just a couple of these. One is the Insurance Institute for Building and Home Safety. They absolutely have standards for safer living, and they do this on not only a commercial level for safer businesses, but they also do it on for safer living for residential. And you can see some of their table of contents. What I like about this standard is that it's using very simple tasks to increase the resilience to a hazard. So it might be the addition of straps into your roofing assemblies, and these are very low cost and very economical. Now, there are other existing models for enhanced resilience, including U.S. Resiliency Council and NIBS. Now, the U.S. Resiliency Council, pardon me, is looking primarily at earthquakes and also looking at a performance rating system. They adopted some of the ASCE-based methodology, and also they're looking at the performance of a building under consideration. And so they're looking at a design basis event. And this is through the ASCE 7 provisions. And what they're really looking at is, what is my repair cost as reported as the function of the building replacement cost when subject to ground shaking with a 10% probability of being exceeded in 50 years. So as we see that they're given some sort of measurement of 10% with a certain life cycle. Certainly when we look at life cycles, we would like them to be much longer, but we know hazards can shorten that period of time in which a building is functional. Ideally, if we look at structures, we may have to add redundancy, which adds into the cost, but we have to weigh that when we look at how we're going to resist hazards in many ways. NIBS has a resilience-based design provision, and here they're looking at a resilience goal by providing some design criteria based on functional recovery time. And I would be remiss if I do not thank Emily Lorentz for sharing some of these slides with me. I saw them very succinctly yesterday in a presentation, and she was so kind to let me borrow some of them today. Their design standard is a technical tool, and it's really looking at the functional recovery standard. And what time limit should be selected, and certainly what type of strategies and provisions should be set in the specific criteria. The concept, in a lot of regards, again, it's a supplemental or perhaps the primary basis for earthquake design of buildings. But again, we have to look across the spectrum of natural disasters and what would take place. Other things that we need to look at are, what is our, how is it going to be defined as a recovery time? Is it going to be hours to months? As I said, when we look at recovery, the rate at which we recover will really dictate our level of success in returning to normalcy. And so how we design is going to be important to how fast we can recover from a disaster. So some of the metrics that have been out there most recently, I borrowed this from a paper from Linkoff, is really looking at what percent of functional do we really need to have immediately after event. And we can see the probability of exceedance and then the return period. So how long is it going to take us to return if we do not recover immediately? And then the levels of resilience. So we could build buildings today and say, we don't really need them to have a high level of resilience. We can deal with a low level of resilience. And I do like this because it's looking at buildings really, as their own identity. How long do we want a church to survive? How long do we need a hospital to survive? How resilient does each building need to be? I also have to say, what kind of structures are there? So if we have a wastewater treatment plant or a bridge that is going to allow us to have egress during a storm event, that needs to have an exceptional or a very high level of resiliency. So again, part of the difficulty in our lens in viewing resilience is, how do we look at the metrics and how is it viewed? Now, resilience and adding resilience in the code is not without some complications. There are a lot of individuals or agencies that would like to not see this occur. Some of this is from our building code officials who really do not want to adopt additional regulatory mandates. Others are lobbyists, such as the National Association of Home Builders, the National Association of Realtors, because they feel that if we build to this higher standard, that it may cause additional economics, which would again have impact on home sales. There's also the problem is we haven't always taken in consideration the land use. So in some cases, we looked at very sustainable buildings were built along seasides, but yet they were struck down during very large storm events. Case in point, if you remove some of your barriers, environmental barriers to some of our hazards, such as sea rise, or if we're having surge and we've removed everything that helps protect us against surge, we can build as sustainable as we want or as resilient as we want. We still may not have a building standing in the end. And the other part of this, as I said, we have to look through different lenses. There's the economic part. There's really a lack of economic incentives today for the code to go in this direction. Many of us would like to say, well, we need to get our insurance agencies involved. And they're willing to look at it, but they're not willing to look at it. So again, there are obstacles. So in closing, I hope I've given you a very broad overview of what is going on in our industry. I always like to look at it as, again, through my life cycle lens, is that, you know, what we build and how we build will all have some sort of environmental factor. And as I say, resilience, we will have these social indicators. These, if we use the right tools and the right design, we can have very long-lived structures. These all have implications on social indicators. But going forward, we have to know that if we increase performance, there are trade-offs. There are trade-offs, and we have to analyze and balance those trade-offs. It could be economically, it could be environmentally, it could be in a performance manner. So really, when we look at what we're doing today in our design, it's really imperative of us to look at the durability and robustness and adaptability of our original designs. How can we intertwine sustainability and resilience in our design? And again, I like the idea of functional resilience into structural design, because if we have a building that stands, such as our hospital, our governmental functions, our water treatment plants, they are going to help support the resilience of the community. But we must make design considerations just not on historical events. We need to be looking at the future climatic conditions and see how we can practically employ these ideas in our design. As I said, there is a very good book out there I recently read on climate adaptation engineering. I like when it's looking at infrastructure. I invite all of you to maybe take a look at it, but it also shows how concrete has a very, very positive role in the construction industry, where it will help minimize the impacts of related storm events, and it is very sustainable. So with that, I thank you for your attention, and if there's any questions, I'll be more than happy to answer them for you.
Okay, do we have, I don't see any in the chat function, but if any of you have any questions, we certainly welcome them. In the meantime, while you're thinking about that, Julie, I'll ask you a question. So within the framework of ACI, you're very much involved. You were the past chairman of 130 and still very much involved in 130, but can you speak just briefly about how you see efforts on including resiliency in various codes, whether it's 318 or 301 or or 350 and others, how you see those efforts going, and what would you like to see differently, I guess. I know it like anything, but
Yes, well, when we started looking at sustainability, it was in 2008 in St. Louis, and it was a packed house. There was about, 400 people that attended that particular event. And then we started the ACI 130 committee, which was heavily attended with 250 people standing only. And I kind of equate when we look at sustainability and resilience, it's kind of like a freight train. It starts and then it slows and it goes through ebbs and flows. And so now that resilience has become very interesting, people are again more interested in what we're doing in 130. But I will say that I think that because of the ANSI standards and the way that we do business at ACI, which is great, mind you, we have to have collaboration and agreement. It takes us a long time to get to the next level. Like, we're still looking at putting out our 130 document. We just had our meeting yesterday. We're finally, after almost 11 years, going to have a document. We have issued a materials document, but again, it takes a long time to get that information out there. And I think also is the misinformation. My concern is that why people think that they understand sustainability and resilience, they really do not. They like to take this view that what they get off the news or they get off of, you know, a little article that they read. And resilience is very difficult, just as sustainability is very difficult. It's just not about one thing over another. It's always looking at the larger picture and larger scope. And so if I can say anything to anyone, it's that, you know, you have to look at the different levels and through the different lenses, because there's many different attributes and things that go into looking at sustainability and resilience. And so you need to have a broad perspective, but then you have to, in resilience, take it down and be very focused and narrow. So I am delighted that 318 has added a sustainability committee in the last year, and we are working very feverishly to get some language that will be in the next code cycle. So with that, I'm very happy. In the same token, it concerns me as well that, you know, a lot of our practitioners are solely focused on CO2 or global warming potential, because we have to really look a little more holistically because of other impacts such as water and other areas that we may not see water as a consideration in the US, but certainly we see it around the world. So that's kind of my soapbox stand for the day, but I am happy that we are moving at least in a forward direction at ACI.
We've gotten a few questions. I'm going to pick one out of these, and then the other ones we may address. There's a comment that I do want to bring up later. And then Julie,
okay,
maybe during the session, you can get into the chat there and answer one of them that's specific to repair. But in the meantime, this one I'll read. When moving towards resilient-based design, you've got to think more about the broader and non-tangible impacts, outcomes over simple quantifiable things like structural damage mitigation. How do you see the balance between qualitative versus quantitative outcomes that we need to understand for resilient design?
Okay, that's a really good question. I mean, you know, I kind of look at it as the devil's in the details. So you have to have quality design to have a quantity impact, if that makes sense. So if I can look at the structure of a building, and let's say that I now design it instead of for the traditional 20-year life cycle for, let's say, the little strip mall down the street, and I now have built it for a 50-year life cycle. This is important because you have a lot of embodied energy in that building. And unfortunately, when we build to a certain standard and it's only 20 years, you are impacting the climate and then impacting climate change by not having a building that serves us for a long period of time, because now you're wasting resources. And in the event of a hazard and it's not built well, it's simply debris and it's going to landfill. So the other part of that is in building it to a little bit higher standard. Let's say that there is a tornado or something that goes through your particular area. Where do people take shelter? Today, if you look at LEED and buildings for schools, they offer building them to a little bit higher standard because they understand that they may become refuge for the community. And so my point is that if you don't build to a standard that's a little bit higher, it may still go through, withstand a storm, but is it habitable? And that's really the devil's in the details, you know. So it may be, we have to look at the quality of the construction, because the quantity output is maybe not for the building, but maybe for the community.